Alrighty. Hiya, folks. Welcome to day 7 of our Games for the Wanes Game Jam. Glad to see you back. Thank you all for joining me. Let me get the Discord message out. There we go. Push that. Let's clean all that up. There we are. How's everyone doing? Apologies for missing yesterday. But we have a lot to do today. And yeah, I want to get right into it. Just give everyone a moment to pop in. I'm going to drop the link there. Of course, this whole stream that we're doing, this whole series is to raise money for Games for the Wanes. So if you have the means, it'd be amazing if you could help support. Absolutely no pressure. If not, though, I totally understand. But yeah, let's get right into it. So the goal for today, actually, so first, where we left off last time is we started generating our 3D world. So we set up this massive terrain. You can drop particles into our simulation and it actually creates the terrain. But there's one problem that I really want to fix to start with, and then I want to get into some optimizations because I think there's some room for improvement here. So the first thing I want to improve is our height map generation. So if we have a look in the scene view here and we go to the wireframe mode, you can see we're creating these extremely harsh edges. And this is obviously really gross for a lot of reasons. It's going to be a pain for us to actually build a character controller that can walk along this. We want to have nice, gently rolling hills and all that. We don't want these harsh, sharp edges, especially these kind of like corners here. And the reason this is happening is because if we go back to our height map compute shader, we are taking the UV and we're finding the particle in that position and then taking its height. The problem is our height map is a higher resolution than our particle simulation. And so pretty much like all the pixels in this region are aligning to the same particle. All the pixels in this region are the same particle. All the pixels in this region are the same particle, and so on. And then we have a harsh cutoff where all the pixels in the next region are the water. There's no blending between the two. And so what we want to do is actually do a blur. So if you remember correctly, let's just pop GIMP open real quick. What we're generating here, this height map that we're generating is actually, you know what? We can see it. We can actually just take a quick peek at it. So if we go into our world builder, let's debug this and pop open that texture. This is the texture that we're generating. And so you can see, if we zoom in on this, it's got very, very harsh edges. Actually, if I zoom in on this, it's going to blur. Oh, no, it's not. Okay, so we can see like basically our particle simulation right here, right? Where we see these harsh edges. So if we were to take this and we were to blur it, let's pop that open in GIMP. If we were to take that and we were to blur this, say with a Gaussian blur, suddenly we have a much smoother height map, right? We can smooth out the simulation. The more we blur it, the smoother it becomes. So that's the goal. So we're going to do that in our height map shader. That's the first thing we're going to do. And then I want to get into some optimization stuff. Yay, another stream. Lonely Turtle, thank you for being here. Appreciate you. How's your day going? All right. So what we can do is what we don't need to do really is to actually run a blur pass. We have all the data, we have our grid of particles, and what we can do is we can just sample the neighbors and average everything out. That's all blurring at the most basic form is really doing. So what we can do is let's go into our fallingsand.hlsl. Let's create a new function called get smoothed height. And what we want is at a UV, and we want a radius. And this is going to be an integer because it's going to run through our grid of particles. Yo, Ilux, 1 sec, watching ads. Sorry about that. Gaussian blur is very expensive and box blur doesn't feel good. Yeah, so we're not actually doing a Gaussian blur or a box blur. We're doing our own kind of very, very rudimentary thing, but I think it's going to work just fine for our purposes. So if you remember correctly, we have a 2D grid containing all of our particles. Hey, Ilux, congrats for getting through the ad. We have a 2D grid with all of our particles. Let's quickly draw this out here. Let's do new. Cool. And just grab the old pencil. Okay, so we have a grid. And say we're filling in our height map, and the height map aligns to a particle here. right? Rather than just taking this guy's height, what we're going to do is we're going to iterate through all of his neighbors. So we'll grab this one, this one, this one, all the neighbors around it. We're going to grab all those heights and we're going to average it out. And that should give us a more smooth gradient, because if these are all the same particle type, they're all going to get the same height. If, say, all these are water, so they're low, then we're going to start slanting towards that side, and it should smooth things out. We don't need to do Gaussian blur. We don't need to do a box blur. We could just do a very, very rudimentary averaging of the neighbors. It's effectively blurring, but if you were to do this to like an actual image, probably wouldn't look very good. Alex, I'm great. How are you doing? It is extremely hot in here today, so I am absolutely sweating, but otherwise I am very good. Okie doke. So let's do this. So we have our smooth height. What we want to do is we want to grab our particle. Actually, we don't want to grab our particle. We want to grab the particle grid position. So we don't have a function for that yet. So let's quickly make that. So into UV to grid pause, to UV, and it's actually just this. We've already implemented that. So we can return into X, Y, and then here we can do grid pause. Ooh, that's Y. Plus grid pause dot X. Okay, cool. So we can grab our grid position. So this is our center point. Ooh, this is our center point, the actual particle that we're working with, and then we can quickly iterate through its neighbors and average them all out. How cold is extremely hot in Scotland? I don't know. It's probably cold outside. I think it's probably like 20 degrees outside, but cold at least relative to you. But specifically in my office, all the heat in Scotland is actually trapped in my office, it feels like. And I think it's pretty much just because I turned this light up to have it a little bit brighter. But anyways, thanks for looking. Have fun with your algorithm writing. Okay, doke. So grid pause is UV to grid pause. And then what we'll do, so for int x equals negative radius, x less than radius, x plus plus, we'll do the same on the y-axis. What we can do is we can add up the height of each particle. So into particle index is this. Okay, so we can grab our particle index using grid pause to particle index, and that'll be grid pause, which is our center point, plus into x, y. So that'll give us the neighbor at the neighboring position. And so we can grab that particle. And so smooth height plus equals particle.height. And then we actually need to check if this is a valid position. So we can copy that function from, what was that? Oh, helpers. We had this on C# side. So is valid position, grab that. Don't need this. So we just want to validate that this is actually a valid grid position, so we're not going out of bounds. Yep, that looks good. So if this is not a valid position, then we could just skip it. Otherwise, we will add it to the smoothed height. And we'll keep track of how many we actually have. Count plus plus, and then we'll return smoothed height over count. So that'll give us the average of all the valid neighboring pixels. And if we go back into our compute shader, where we're generating our height map, instead of doing particle.height, we'll do get smoothed height and pass in the UV position. And then we'll normalize all that. Oh, and the radius. Let's do a radius of 2 for now. See what that looks like. So we're going from this harsh edge to a runtime error. We just need to restart. Okay, so those are all still flat. That's good. And then if we add some water, that is coming through flat, actually. Why is that coming through flat? Okay, so we run through smooth height is 0, grid pause is the center point. We add the offset based on our for loop to the grid position, check that. If that's good, grab the particle, we add the height, add the count, smooth it out, or average it out. Morning, CV Hamilton. And over here, we take our UV. We take our UV, we get our smoothed height from it. We normalize that. That's correct. And then we multiply it by the height map max. That's correct. So what are we missing here? Let's try, if we just do water, is that working at all? So let's do something there. Something's definitely happening. X, Y, that should just be less than, actually. Why is everything coming through flat? Why is x is minus radius, y x less than radius, y is minus radius, y less than minus radius, or less than positive radius. We add that to the grid position to check that. If it's not a valid position, we continue. Valid position looks correct. We then grab the particle index at that position, grid pause to particle index. Yep. Grab that particle, yep. Add its height to the, let's just call this total height. Cool. Average that. That all looks correct. Fun with grid math again. Smooth height. Okay, I think our clue is that we're getting this weird valley here. So something on the, I guess, x-axis of our, oh, we don't need this anymore. Of our simulation is not working. What a lovely start to the stream. Okay. Radius, let's just do a radius of 1. See if that looks any different. So something on the left side. So that would be when x is less than, the x-axis of the UV is on the lower end. Something there is working. Do you ever comment your code, header comments on personal projects? I do it as a habit, but it's time consuming. I can come back to it a year later and understand what I do. It kind of depends. It depends like how complicated the code is. I don't do like header comments as like a rule. I know some people kind of enforce that as a rule. I only do it if there's like something that is intentionally weird, something that's intentionally like out of the norm, or if I think it's going to be confusing to look at in the future. And obviously you don't really know if it's going to be confusing to look at in the future, so it's kind of not the best practice, but that's kind of how I think about it. Because the problem with leaving a lot of comments is that they tend to fall out of date or fall out of sync with the actual logic of the code. And so you have all these comments that are kind of misleading because you don't know if they're actually trustworthy or not. So I think later into a project, I'm more likely to leave comments than I am earlier, if that makes sense. Guys, this is exactly where I did not want to be starting this stream, is stuck on more grid math, because I feel like we spent enough time on this. There's something very basic I must be missing here. Sum of height, count as 0, yep. We add up the sum height. Divide it by the count, that's fine. This should be, like, dead simple. If your comments are out of date, your code's around them as 2. What I mean by that, Mystic Coder, is more that you write the code, you write the comments, and then a month later you go and you fix a bug and you change something about the code, and then suddenly the comment is referring to old code. It's not kept up to date. Like, I find, because you have a compiler in a language like C#, you kind of have to keep the code up to date, but there's nothing that enforces that the comments are kept up to date. And so they just have a tendency to kind of drift over time. That's just kind of my experience, both working on my own and working in teams. I just have seen a tendency for comments to kind of get out of date and become misleading or confusing. And you have to kind of measure or you have to weigh the kind of cost of keeping those comments up to date, writing all the comments and all that, versus just rereading the code and reinterpreting it, and whether you're actually saving time. But I think comments do have a place. I just, like, as a rule, I don't enforce them in any projects that I work on. Help didn't follow. Yeah, no worries. Basically what we're doing is we're just trying to get the average height of all the particles in a region of our grid. And so this averaging logic is dead simple, but for some reason we're getting a very strange issue. Comments versus documentation. Yeah, I think there is kind of a difference, right, between the two. Hey, Tony loves the music. How's it going? Yeah, it should be very easy, Ilux. But something weird is going on in our x-axis here. I'm wondering if I made a mistake in one of these. Okay. Let's have a look at where we started at. Maybe I butchered something here. Okay, UV to particle index. So this is our UV to grid position. So we return XY. Yep. Grid pos to particle index. We return y times width plus x. Yep, that's fine. UV to particle index, we take UV to grid position, which was this, and then grid position to particle index, which was that. That's all exactly the same. Let's do, just to make sure I didn't butcher the original logic, let's do this. Heightmap.compute. Let's just grab exactly what we were doing before. So if I roll this back. Okay, so that's still working, which means kind of our internal helper functions are still correct. So it's just in this smoothed height that we have an issue. Grid pos to particle index, grid pos to particle index. Yes. Take the particle at that index, add up its height, add up the count, divide it. Why in the world are we getting this? Forgive me for coming late, but how long is this game jam? What's the ultimate goal? So the jam ends August 31st, I believe. But we're only working on this game on stream, so I'm only working on it like 2 hours a day or so. But the idea is, I was very much inspired by these pieces by Taylor Brooker. She creates these incredible embroidery landscapes. So my thinking was, what if we create a tool where you can kind of embroider an environment with an aerial kind of landscape view like this, but then you can actually go and walk around that environment in 3D. So we have what's called a falling sand simulation over here. So you can add particles to this kind of simulation, and they always kind of fall into the environment. And then we can kind of mix elements. So if we have like water and soil, they mix to create grass. And if you have a lot of grass, then trees will spawn, stuff like that. We have rocks that kind of stay still, and we have like kind of physics and all that. So now what we're working on is actually being able to like go in, so be able to basically generate a terrain in a 3D world from this simulation. So extrude a result to a height map, I guess. Yeah, essentially, yeah. So we have that working. If I go back to where we started, So let's roll this back. So we have that working, so we can generate this height map, but it's obviously very, very harsh, right? Like these edges and everything are far too extreme, so we want to smooth that out. So essentially all I'm doing right now, all I'm trying to do is just basically smooth out the neighbors so that we take the height map and just kind of like even it out a little bit. Shouldn't be x less than radius. Yep. That's what we have, right? Unless you're talking about somewhere else. So we go from x minus radius to radius, y minus radius to radius. That should basically run around our center particle that we're working with. Unless I'm not looking at what you're referring to. Minus radius to positive radius, minus radius to positive radius. Hey Manuel, how's it going? We're off to a rough start. This was supposed to be a very, very basic thing. But we're getting a very strange bug. X less than radius shouldn't be less than equal. So if like radius is 1, we would go 1, 0. Oh yeah, you're right. Yep. I don't think that's what's causing our issue. So we're starting to see the smoothing, but for some reason we're only getting it on the x-axis. This makes no sense to me. Somewhere we are messing up our axes. But thanks for the heads up on that, you're right. Manuel is alive. XY, yes. I'm looking for if we're using the x-axis somewhere that we don't intend to be. Y times width plus x, that's correct. X and y. This is going to be one of those things that is like so silly and stupid and obvious in hindsight when we finally find it. Isn't it wonderful to be blessed with some early stream issues? Yeah, it's great for my sense of imposter syndrome, for sure. Currently in the garden watering plants, nice. Grid pause to particle index. Check pause, that's correct. All code ends up being what the hell was I thinking after the fact. It's true. It is very true. It's always some silly little thing. Okay, let's double check this logic because I'm kind of at a loss for the other function. So we take this, so we know that the heights are coming in from -1 to 1. So our smoothed height gets averaged out. We normalize it from -1 to 1 to 0 to 1. We multiply that by the height map max, which is what Unity defines as the maximum value you can put in a height map. So that's all fine. The UV is correct. I'm grasping at straws here, but I was wondering if there's maybe some float to int conversion issue. That's all fine. Oh, guys. UV to grid pause. Yep. This is riveting content, I'm sure, but we kind of need to get this working. Grid pause to particle index. Let's do let's just debug something here. Okay, so we're getting a slope. So if I'm outputting the x-axis, we are getting a slope. That's correct. And y, getting a slope. That's correct. Okay, so the UV's fine. It's probably going to throw an error, but... Why? This is the weirdest part about this. Why is it only on the x-axis that it seems to be doing anything? Anyone have any ideas on that? Oh, should just look at this warning. Get smoothed height implicit truncation of vector at line 14. Oh my god. There it is. That needs to be a float too. There we go. It's always the stupid thing. There we go. Okay. Okay, so now we're getting a nice smoother height map. All right, we're back on track. So if I increase the radius of this, it should get progressively more and more smooth. So if I go to like 4, it smooths out more. If I go to like 10, it's basically flat. Let's try 1. Still quite harsh. So I think like 4-ish feels good. Gives us a nice gradient. Maybe 6. Yeah, there we go. It's not an error. One thing that's kind of annoying with HLSL is it'll actually just kind of like, it'll cast it. So if you have a float 2 and you cast it to a float, it just takes the x-axis. You do get a warning, but if you're sitting here staring at the code and you're not looking at the warnings, then yeah, I guess that's your own fault. So, but anyways, we got it working. So that's great. And let's just double check that I left that valid position. Yeah, cool. All right, and that explains why we're only seeing it on the x-axis, because the y-axis was basically just being chopped off. So one issue is, that's actually, I'm not sure if this is an issue. If we have just like if we have like a single water particle, like we have 3 water particles here, it's basically just going to be flat. But I guess that's fine, because it's basically just like a puddle, as opposed to like a lake. Cool. Okay, awesome. So the next thing I wanted to look at is, if we pop into the profiler, I noticed something quite alarming. So if we open this up, this guy right here, I don't know if you guys can see that. I can't zoom in on this at all. But there's this function here, terrain.readback height map. So what's happening is, just to kind of recap what we were doing, we have our whole simulation, and it's on the CPU, right? So we have all of our entire particle simulation. It's on the CPU. We pass all the data to the GPU to generate a height map. But because we're using Unity's terrain system, and the terrain system wants to generate colliders and all that kind of stuff, LODs, it's going to then take our height map, copy it all back to the CPU, and it's going to hang while it does that. So this is taking 5 milliseconds. So that's like nearly a third of our entire frame budget at 60 frames per second. We have 16 milliseconds to work with, and 5 of it is going to this terrain internals from Unity. So I think what we want to do is actually just completely do away with Unity's terrain and not use it whatsoever. So the goal is, we're going to replace this height map with a with a plane. So let's do that real quick. And then we'll write a vertex shader to just apply our height map to that plane. We don't need any of that data back on the CPU. We already have the particle simulation on the CPU, so all that time spent copying it back and reading through and interpreting the height map is completely wasted. So you can't make a single water hole. I mean, it wouldn't... We're going for kind of a low poly look anyways, so it wouldn't really work to just have like one hole that kind of like drops down into a deep lake. You can have a little puddle, but not... If you want to make a lake or like a deeper body of water, you have to have more water. And I think that makes sense. So let's create a plane. This will be our new terrain. And we'll, just to save ourselves some effort, align it exactly the same as Unity's terrain is. So the kind of coordinate 0, 0 is at the bottom left. And then let's subdivide the heck out of this. So we have lots and lots and lots of vertices to work with. That's probably too much. So we get about 1100 vertices to work with there. And then what we can do is basically do the exact same thing that we're doing in our height map shader, but just move it into a vertex shader. So let's give that a go. So we have our terrain. And he's tiny. So if we scale this up like 100 times, we are going the wrong way, but that's fine. Actually, no, that's not fine. Let's fix that. Come on. Okay, so that lines up perfectly. And then we can get rid of our terrain. Okay, so we have this mesh, and if we look at the wireframe, we have lots and lots of vertices to work with. And so we can just extrude each of these, basically raise them up or down based on our height map. And in fact, we don't even need to generate the height map anymore. We could just do all this in the vertex shader. So let's get into that. So we have our terrain shader. Let's quickly apply that here. And if we pop in that, so inside of our vertex shader, we are going to take our height map computation. We're going to do basically the same thing. Where did it go? Here. Okay. So v.uv. How about that? But instead of writing it to an output buffer, what we're going to do is we're just going to raise the vertex. So v.vertex.y plus equals normalized height times some value. So we can define that here, max height. And let's say it's, I don't know, 20. Okie doke. So let's give that a go. And in our world builder, we no longer need to run the height map compute shader. And we actually no longer need the splat map, so we can get rid of all this crud. We'll clean this up after, once we know that this works. And we can get rid of the terrain requirement. Get rid of these, get rid of all this. Cool, and that's going to take a ton of pressure off the CPU to copy all that data back. Alrighty, let's try that out. So nothing's happening. Why is that? So we are providing that data to the global, yeah, what's in the shader global. So we have access to the particles, the width, the height, we have all that stuff. If you're really sick and twisted, you could pass a 4-vertex plane and tessellated shader into the grid. You could, but honestly, tessellation is a hog on performance. It's actually really, really far worse in my experience than just having a high poly mesh on most GPUs. Even so, like my last game, we had a terrain where you could kind of walk through a snowy environment and kind of carve out paths in the snow. The tessellation was like just an absolute nightmare on that, and actually generating a whole bunch of planes that are very, very high poly and kind of like fitting them onto the terrain and doing the subdivision on that, or not, sorry, not the subdivision, but the snow carving on that worked way, way better, even on the Nintendo Switch. So I kind of nowadays avoid tessellation like the plague if I can. Yep. Yeah, tessellation just is like an absolute hog. Okay, so we're getting nothing here. That's kind of okay. Let's just undo this. Okay, so we can see that. Now let's render the UV just to debug that. F4 i.uv 01. Okay, so it's actually backwards. We want that flipped around. If you think about it, right, like the thing with tessellation is you're regenerating all that geometry every frame, and you're adding quite a few passes to the you're adding quite a few passes to like the whole shader pipeline. You're adding the tessellation stage, the domain stage, the geometry stage, I think. So you're adding a ton of stuff that needs to be done there, and you're kind of redoing that work every frame, right? If you just have the geometry, you just need to send that data to the GPU once, and then it's there, it's done. So unless memory is a major bottleneck, or if it's, if you have a massive plane, right, that goes on for like a kilometer, and you're only ever going to subdivide like a small portion of it, then it would be very redundant. But if you kind of break that up, add LODs, and you just use like the high poly version nearby, near the camera, it's going to be much more efficient than tessellation. Okay, what I want is the bottom left to be at 0, 0. Yep. Yep. Okay. I get what you're saying. Depends on the use case, I guess. Yeah, I'm sure. Yeah. There's times where tessellation still makes sense. I just try to avoid it where possible. Okay, let's move this so we're not blocking the camera. Okay, so actually, let's move it like this. Like that. Minus 100, minus 100. Okay, so this is our kind of simulated world. We know the UVs are correct now. Avoid, if for no other reason than it's a lot of work. Yeah, it is a lot of work. It's a pain to set up. And it's the kind of thing that you'll like never actually remember how to do, so you have to Google it every time, and like figuring out how you like do the edge length functions and all that kind of stuff is just such a headache. Okay, so we have all that. Okay, so we're offsetting this using the normalized height times max height. Max height is defined as 10. Oh, it's 20. That might be too much. And we're also no longer restricted by this. So we actually don't need this, I don't think. Yeah, cool. So if I add some soil and add some water, cool. Yeah, now we get now we're getting the vertex displacement. We don't need a terrain, which is great. So I get rid of that. I think the max height is probably a bit too much because this is actually normalized. So let's do 0.1 and let's bring back our colors. Cool. Okay, so we have a smoothed out plane offset based on the simulation. We no longer need to use the terrain, and we can confirm that our render time has gone down. Let's go analysis, profiler. So our player loop's down to 4 seconds. I believe it was 11 seconds before. Yeah, 11.27. We've gone down to 4.2. Yeah, nice. So that's much more efficient, and we no longer need to do any of that terrain nonsense. And then when we do get to having a first-person character controller and walking around, we don't really need the collider of the terrain anyways. So the one kind of downside to doing this with vertex displacement is that your colliders are inaccurate. So if I had a mesh collider on this, it would still just be a flat plane because the CPU collider doesn't know about the vertex displacement. But we do have the particle simulation, so we know the height at any given point, and we can actually just do this. We can do the same thing on the CPU that we're doing here, this get smoothed height, which is really efficient. We're just calculating the height at one point, which is where the player is, and we can just put the player on top of the plane at that height. So we don't even need physics for that. This is current Unity version. I think I'm like a week or two behind, but yeah, 6.1.8. I think they're at 6.1.10 now, so I might be like a month out. Nice. Okay, so we're smoothing that all out. Now actually what we can do, which is basically the exact same thing, is we can smooth out the color as well. So we get a bit of a gradient as opposed to just these like harsh pixels. So let's do the same thing. So we have get smoothed height. I'm just going to grossly copy and paste this. Get smoothed color. And rather than some height, we'll have some color. Cool. And then train shader. This will be get smoothed color. UV 6 as well. And let's actually move the smoothing out into a parameter. So height map smoothing. And actually we can do a separate one for this, color smoothing. And we should see a nicer gradient. Yeah, cool, cool. And then if we bring back our ocean plane and we fix the position of that, we're starting to get a bit of a terrain here. And it looks a little bit better than what we had before. And we can start adding textures and all that kind of stuff, but this kind of like smooths things out a little bit. So let's fix all this up. -1. So this is our ocean. This is our terrain. This is like the world boundary rim. Let's bring that down. Cool. That's neat. If I do say so myself, I think that's pretty cool. Did you only use handcrafted shaders in Feral North, or was there an element of shader graph? Pretty much everything in Feral North was... I can show you. Pretty much everything in Feral North was written in HLSL, so like handcrafted shaders. So if we go into like rendering, shaders, coloring. So this is kind of my main Uber shader. I have coloring lit. This is kind of like my lit pass. I have a whole bunch of other stuff like for particles and snow and some different effects and everything, but 90% of objects in the game used this shader here. And you can see it's a big beast. And it does absolutely everything, has all kinds of effects in it and all that kind of stuff. And yeah, every pass was kind of written by hand. It's a big pain. It does adapt, if I zoom back in here, it does adapt a lot of the kind of default URP stuff. So if I go into, where is it? Coloring, overrides. So these are kind of overriding the default URP stuff. So like the lit forward pass, there's a bunch of modifications I made to that, stuff like that. But yeah, I definitely followed like an Uber shader architecture for that. Aside from a few effects where it just made sense to do something completely separate, there is a couple shader graphs for VFX graph, because with VFX graph you can't just write you can't just write your own shaders for VFX graph. You have to use shader graph. So there's a couple times where I did that, but pretty much everything was done in HLSL. However, for my next game, I've reluctantly and begrudgingly moved to shader graph, because what I'm finding is that having to maintain all the different passes, like depth pass, shadow passer, all that kind of stuff, was super time consuming for this. And especially if you're upgrading URP, they're constantly breaking things and all those different passes, things like light baking, all that kind of stuff, which they're constantly changing the APIs, but there's no documentation for. It's a huge pain. So what I'm doing now is more akin to this, where we have, where is it? Shaders. So we have a very basic graph. Once this opens up, we have a very basic graph, and then inside of that we have like one HLSL function, like a custom function, and then that kind of does all the logic inside of it. So you get all your lighting, all your different passes, all that kind of stuff is kind of maintained by shader graph and like the URP team. So like here, so we have apply falling sand. So if I go into that function, right now it just looks like this, but we basically take like the main texture in and we output a color, and then we pass that into, you know, the main graph. So you can get kind of the best of both worlds. I'm finding it's not perfect because shader graph has a lot of issues, like it's missing like support for the stencil buffer and stuff like that. So there's some stuff that you can't really work around, and it's quite annoying. But I do think it's more time efficient than having to maintain all these different passes and dealing with all the constant Unity changes. Yeah. Yeah, the Uber shader thing. Yeah, exactly. If def compile time exclusions based on this and that, I assume. Yeah, but I try to avoid compile time exclusions as much as possible, because the one real nice benefit with an Uber shader is you can batch absolutely everything. Like especially with the SRP batcher now, pretty much everything in the game can be done in one batch. And as soon as you start having those compile time flags, you lose the batching. So I try to avoid that as much as possible, unless there's something really expensive that can't be like simply like multiplied out or whatever. Anyway, so we have yeah, we have our terrain generating. I think that's pretty cool. I think the blending on the colors doesn't look very good. Why is that happening? I want to start working on art direction tomorrow. I have an idea based on Sackboy. I think we could do like a cool, like kind of like threaded environment, so it all looks like it's kind of stitched together. And we could do like a just a basic triplanar shader to like have everything look like it's all stitched together, like all our trees and everything. So I don't want to worry about that too much, but I do want to understand why this is so chunky. By the way, are you using LFS in Feral North? No, I'm not. I try to avoid LFS as much as possible. Any tips how to configure that? Somehow the reference broke very often for me. Yeah, LFS. So there's two problems with LFS. The references. So for those who don't know, Git LFS is for large file storage. So if you have files that are greater than 100 megabytes, you can't store them in the repo. You have to use something else called LFS, and it tries to link it to your repo and your change history, but it's a pain. And the links always break, and it's also very expensive, because every time you commit a change, it's adding like another 100 megabytes. So it's very expensive very quickly. So I avoid it. And right now, I can't show you because I haven't announced the project yet. In my main game, I do have two Blender files for all my kind of character models that are well beyond the 100 megabyte limit. So those ones, it's like really gross, but I'm using Google Drive, and I have like a little Google Drive plugin that's always running that's like keeping those files backed up in Google Drive, but it's like kind of hideous. But the only reason I'm kind of like justifying that is because those blend files are like binary files anyways. I'm never really going to like deal with merging them or doing anything like that. So I need to look at like plastic SEM. Supposedly plastic is a lot better with those large files. You could go back to like actual SVN, but I don't really want to do that. I love Git. But yeah, it's like a really gross solution that I don't recommend at all, but it's what I'm currently doing. Hi, Adrian. How's it going? How's your day? What do I work? So we're working on a game jam game here where I'm always pulling up this image. I should just save it somewhere. It was inspired by these embroidery pieces by someone called Taylor Brooker. She creates these amazing landscape embroideries. So what I wanted to do was create a game where you can kind of embroider an environment and then go in and walk around in 3D. So we've got that kind of working where we can create an embroidery, we can add kind of different elements, and the elements kind of interact with each other. So like water and soil creates grass, stuff like that. We have rocks that we can add. We have like a full physics simulation on all this. And then, so what we're working on now is generating an actual 3D representation of that through some shaders to generate this kind of like height map. And then the next thing to do will be start walking around that environment and adding things like trees and birds and all kinds of animals and all that kind of stuff. Git will tear your soul apart. Git will tear your soul apart. It will, but when you like come to understand Git, it's an amazing tool. I think it's like one of the greatest pieces of software ever created. It does have its quirks and it does have a definite learning curve, but when you use it and you use it right, it's amazing. It's an absolute lifesaver. Okay, yeah, so I wanted to look at why this color smoothing is so pixely, so chunky. And I think I might know why. So obviously the lower we go with that, actually these should always be ints. These should not be floats. I think what's happening, so if we drop that down to 1, obviously we're only averaging with one neighbor. So here we can kind of see where this portion of the UV is aligning to one particle, and then we're averaging all these neighbors to get this guy's color. And so if we increase that, we get a more gentle blur. However, I think the right thing to do would be to weigh the blurring based on where inside that particle we are. So if you're at the center point of that particle, you'd basically get what we have now. But if you're on this side of the particle, it should be more weighted towards this, whatever's on this side. And if you're on that side, it should be more weighted to what's on that side. Or we just crank it up. I think that's the proper solution. I think we'll save that for another day. But for now, we have a rough blending going on. Grit is the greatest tool ever. Yeah, exactly. 100% agree, Ilox. It is one of the greatest pieces of software ever, or one of the most important pieces of software ever created. It's great. I picked Gaia free from the store. Nice. Yeah, we got that last week. Someone tipped me off that was free. We picked that up on the stream last week. Having to explain Git to non-tech team, yes, that is a pain. That is absolutely a pain. I will grant you that. I think you want to kind of shelter non-technical people from Git as much as possible. Trying to explain it is a bit of a losing cause. Any tips to branch management with non-tech team like designer and artist? That's a good question. I've never brought designers or artists into Git. I did bring my composer into Git for my last project. So we had an fmod repo. What is it? Feral North Audio? So I brought my composer into Git for our last project, and I gave him some, you know, guidance and overviews and all that on how to use Git. I prefer Git on the command line, but I got him using GitHub Desktop because it kind of saves him having to deal with any of the raw, you know, Git commands or any of that. He can just click like download latest and upload my changes. But I guess my main tip would be I created this and I pull this into Feral North as a subrepo. So you can see here, Feral North Audio is linked as a subrepo. And so that means that the only changes that ever happen in here are audio related, and he doesn't have to download the entire history of the entire branch. He doesn't have to deal with like all these other files changing that he doesn't care about. He just has the audio in a single repo. And so that helped a lot. And the other thing was that if he broke something, it was really easy for us to deal with because like there wasn't a lot of audio changes happening all the time. Like this entire history, well, it has quite a few commits actually, but like it wasn't changing every day. It was changing once in a while kind of thing. So it just made it a lot easier for us to manage. So that would be kind of my recommendation. And yeah, it's pulled in as a submodule. But I think like, you know, generally speaking, you probably want to shelter non-programmers as much as possible from Git. So using subrepos, reducing the complexity as much as possible for them. So having a very simple workflow. Don't have them like doing pull requests and all that kind of stuff. Just like keep it simple for them. And then you can deal with the complexity in your main repo by pulling things in as a submodule and all that kind of stuff. Most devs don't know how powerful Git is or don't bother learning it. Yeah, it's a kind of like big pain point when you hire new developers. So when I was working as a tech lead, we would hire developers. They'd come out of school and they wouldn't have any experience with Git. I really think Git should be taught in school. But like, yeah, week one was oftentimes like just getting them comfortable with Git and the workflows and pipelines and PRs and all that kind of stuff. And, you know, dealing with merge conflicts and branching and all that kind of stuff. But it's super, super powerful. Once you know how to use it and you use it well, it's amazing. It's an absolute lifesaver. I can't tell you how many times literally like projects have been saved by Git. It's a great tool. The other thing, so Wild Heaver, one other thing you could do is if you really want to bring in designers and artists and stuff, you could look at a simpler version control tool like SVN or something. I know it's like super outdated and it's another thing to have to manage, but it is generally a little bit easier to kind of understand. So that might be another option. Okay, let me pull up my to-do list here. So we've smoothed out the plane. We've replaced the terrain with a subdivided plane, which is much more performant. I want to also look at one other thing. So going back to the way that our simulation actually works. So currently we're doing this. If we have a sand particle, we check if any of the neighbors are grass, right? And if that's true, then we check in a 20 grid or 20 unit radius if there's water, and that's how we have the water expansion going. And that's super inefficient, and it scales quadratically, so it's like ON squared, because if we go back to our falling sand simulation guy, if we have, so this is what I'm talking about. So if we're a soil particle and our neighbor is water, or our neighbor is grass, and there's water within 20 units, then we want to convert to grass. But this is really inefficient because this is going to run across, this is going to do 400 checks. It's going to check 400 neighbors, right? So if it was like 10 by 10, we would check 100. If we do 20 by 20, it's checking 400. So it's exponentially growing, and it's really, really inefficient. And this is probably the most taxing part of the game currently. It's like using a lot of CPU resources. So what I think we could do is we could do a bit of an optimization here. I don't have a better idea for how to do this check, but I do think we can filter out a lot of the checks if we knew, so this is our neighbor detection here. If we knew at this point that column X, so if we were to say if column X has no particles of type equals particle type, continue, we'd be able to skip that entire column and a large portion of the checks. So it's still, if you were to do big O notation, it's still like ON squared. I don't have a better idea for how to fix that, but this will at least reduce a lot of the checks that we're doing. Does that make sense? Just don't try to teach artists how to use CLI tools. Yeah, that's a big help. That's a big help. I think using GitHub Desktop, if you're going to do it, using something like GitHub Desktop is going to save you a lot of pain. Ed, Git in uni, but not sufficient IMO. Well, it's good that they taught that. They didn't teach that when I was in school. But I watched conferences and nerded about it so much I ended up being Git manual on my teams. Awesome. I love it. We had Git and data science course in uni, so while it's not taught as its own course, it's still included. Oh, that's great. Okay, I'm really glad to hear that. And taught where it makes sense. It's really helpful. Yeah, totally. You have a non-lerping shadow problem on your terrain. This is the type of comment I was talking about before. You have a non-lerping shadow problem. We don't even have shadows on the terrain, but I think you're talking about this like chunky color system. So I think the solution to that is we need to actually, rather than just averaging all the neighbors, we need to weight it towards the side we're on. But I don't want to do that today because I think tomorrow we'll probably start looking at art direction. So that'll be something to fix there. I think that's what you're talking about though. Oh, shading. Sorry. Yeah. Okay. So you were saying that. Yeah. We'll fix that when we do some art direction stuff tomorrow. Fix that chunkiness. Okay. So yeah. So I want to basically reduce the amount of work that we're doing inside this loop. So I think what we can do is we can add another job. So let's do a falling sand column cache job. I don't know what else to call this. Oh, cool. I was messing with this earlier and it's still here. I was doing a little practice run of this, but I think we can actually just reuse though it's already here. So yeah, so basically what I was thinking when I was testing this out earlier is we could basically, so if we run through every column of our grid, so if we have a grid, right, and it looks something like this. If we run column by column, so each job will be responsible for one column of the grid. If we basically get a not a list, but we do a bitwise operator to get a single int that contains all the unique types of particles in this list. So basically, if we go to our particle type and we make this come on. Why is this not... Sorry, I gotta restart Rider. I don't know why this happens. Rider gets all confused. But we basically get a single int that contains all the unique types of particles in that column. What we can do is when we're checking our neighbors, we can very efficiently say, if this column doesn't contain a single one of the particles that I'm looking for, like particles of the type that I'm looking for, we don't even need to check the column. You know what I mean? So that will let us filter out a lot of checks. I gotta get Rider going again though. So for this to work, we need these to be all powers of 2. And the way that this works is that each of these, when you represent it in binary, 0, 2, 1, 0. Has a different binary representation or is assigned essentially to a different flag in binary. And so we can kind of combine these. So as soil and water becomes 0, 0, 1, 1, right? So if we have this value, we know that there's soil and water in that column. If we had 1, 1, 1, 1, we would know that there's soil, water, rock, and grass in that column. So it's an efficient way to kind of store everything into a single integer. And so it's called a bitwise operator. And the syntax for it's a little bit weird, but we were doing this the other day for the, not the transform job, what was it? The movement job. So in this guy, it's kind of the same thing, right? So we pass movement style. We use a bitwise operator to say that this particle type can move down and down diagonal. This one can move down and down diagonal and horizontal. So we're doing the same thing where we're going to say a column has grass and water and, you know, rock or whatever. So I was messing around with this earlier just to prove that this was going to work. So here's what I came up with. Normally I try not to work on anything off stream, but I just wanted to verify this is going to work before messing with it. So basically what I'm doing here is because we're working column by column, so this instance of the job is going to be responsible for an entire column. So for y is 0, y less than height, we start with an empty particle. We get the particle in that position, and then we use a bitwise flag to add it to our particle type. So at the end, this particle type is going to, so if this column had like empty, empty water rock, it would look like, 0, 0, 1, oh, sorry, 0, 1, 1, 0, right? Because rock is 0, 1, 1, 0, 1, 0, 0, and water is 0, 0, 1, 0. So when you combine them, we get this. So we don't need to actually define an enum for that. We just know that this integer contains that value. Hopefully that makes sense. Bitwise operators are very, very weird. But anyways, so we can add this to our list of jobs that we're running. And if you have questions, let me know, because I know that was a very scuffed explanation. So falling sand column cache job equals width is this dot width, height is this dot height. So your columns are column major. I'm not sure what that means. What does that mean? They could be. I'm not sure though. And output, we need a new array for this. And instead of, we don't need one for the entire grid, we just need one per column. And then columns, what do we call it? Output. Okay, and we can run that. Job handle equals column cache job dot schedule. And we run one per column. Column dot length 64, and then depends on the job handle. So what this is doing is our schedule here is adding dependencies. So the falling sand, so the movement has to run first, then we can update our column cache, then we can run our transformations. Means indexing into the array is column first, not row, like matrix. Oh yeah, yep. Then in that case, yes. So, yep. Okay, so that should do it. So we're gonna run the movement, we're gonna cache what's in each column, and then in here, in our movement job, what we can do, sorry, not our movement job, our transform job, in our neighbor check, what we can say is, we need to know if this column contains has any instance of the particle that we're looking for, otherwise we can just skip it. So if this dot, oh, we need to pass it in. Column, what is it? Native array, particle type. Column cache. Let's pass that in. So if this dot column contains the particle type, so this will tell us this like weird check here is basically saying, does the integer in this position contain these this bit, this flag? So we can skip that if not. But this actually, we don't want X, we want grid pause plus X. Plus X. And we need to know if that's actually a valid index. So column is this. So if the column is greater than 0 and it's less than that, and it does not contain that particle, then we can skip this and we don't need to do any of those checks. Let's give that a go. We shouldn't really see anything different. Oh, we're going to see an error. So for those who are joining for the first time, we are doing this stream for charity. So every time there's a compiler error or a runtime error, I'm donating £2. So we'll track that there. So out of range exception was thrown. Why was that? Because we have these spools assigned to a particle type, but we changed the definition. So this should be, we have a spool for soil, water, so this should be rock. Okay. So that all looks the same. Can add water. Cool. Cool. Nice, so that still works. And the last thing I was thinking that we can do, right now what we're doing is every frame we are running the simulation, waiting for it to complete, and then rendering it. I don't think we need to be that precise with it. So what if we were to do instead, so right now we run in update, we schedule all the jobs, and then in late update, just before we're going to draw the screen, we force them to complete. But if they're not done yet, we're going to sit here and we're going to wait for them to be done. I really don't think we need to do that. I think what might make more sense is to actually just complete it on the next frame. So we kick off the simulation this frame, and then we render it next frame. And I don't think you'll be able to tell that there's any lag there. So if we move that there, we can get rid of our late update. Yep. And then we have our click. So this is where we're actually drawing. So if we track this, it's like click pause equals that. Yeah, we still need those. So if we have a click pause, then we will insert the new particles. And set that back to null. Cool. So if there was a previous job from the previous frame, we complete it, we update all of our shaders. If we clicked on something, we'll insert those new particles, and then to finish off, we'll start the simulation, which will be complete next frame. So again, we shouldn't really see any difference, and we shouldn't be able to notice that there's any kind of delay there. But I think it's gonna be a little bit more efficient, especially on lower powered machines where it's potentially not going to finish the simulation between starting the loop and rendering the frame. Cool, yeah, it's still virtually real time. You cannot tell that there's any delay there. But that should be a little bit more efficient. All right, so those are the optimizations I wanted to run through. And then the next thing I want to do is add a new particle type. So we put this out for playtesting last week. I'll pop the link in the chat. Oh, pop the link in the chat. We put this out for playtesting last week. And so one of the things that was pointed out is that we want to have like sand essentially between water and soil. So essentially sand is going to behave exactly the same as soil. It just doesn't turn to grass. And I think rather than adding a new thread for that, we'll just place sand always along the border of grass and water. So what we can do in our transform job, well, first of all, actually, we need to define that new type. So let's do that. So this would be sand is 16. And actually, we don't need this anymore. Okay, so we need to add this to our color mapper. This is still a very ugly thing that I want to get rid of at some point. Is that a constant? Yeah, cool. May I ask why you do the this dot pattern? It's just, so I know a lot of people don't like that. I prefer that, especially, so my kind of naming, I follow this convention in virtually everything. So anything that's public is capitalized, anything that's private is prefixed with an underscore. So for privates, I mean, so technically you don't need the this, because you could just read that and you would always know, okay, that's got to be a public. This has to be a private. This would be an inline. So you don't technically need the this. It's just a habit and something I prefer. I find it more readable this way than like interpreting the capitalization, the underscore and all that. But it is definitely redundant. Very redundant. It's just something I do. Right, so this should be sand color. And I think actually now that we have our terrain shader, we don't need this color mapper at all anymore. We can just do all that in the terrain shader, but we'll save that for tomorrow. Falling sands dot particle type dot sand uses a sand color. Cool. And in our transform job, what we're gonna do is we're gonna add a buffer between, we're basically gonna add a buffer between water and soil. So if we have soil, if it has a neighbor in one radius of water, then we're going to transition to sand. Sand. Else if it has a neighbor of sand. So if we're soil and we're touching water, we turn to sand. If we're soil and our neighbor is sand and there's water nearby, then we turn to grass. So that should basically give us a 1 pixel or 1 unit sand buffer between water and soil. So let's see what that looks like. Oh, actually, you know what? We're getting an exception. We need to actually complete this job because we're not doing that anymore. So this job not complete. Should get rid of that. Okay, so there's our soil. And if we add water, we get an exception. Let's add that to the error list. So what's going on here? Cannot see. Let's, oh, you know what? I think there's a few other places we need to update. Let's do, let's check where all the places this is used. I think there's somewhere we forgot to update. So we have sand there. And we need sand here. I think that's it. So sand is going to behave exactly the same as water, or sorry, exactly the same as soil. It's just not going to turn to grass. Okay, we have something happen in there. I think our colors might not be different enough. No, they're quite different. Let's remove the blending just so I can see exactly what's in each position. Oh, actually, you know what? Hang on. Okay, so if we set soil to be pink, just to really visualize this. So we have our soil there. If I add water, we see like 1 unit of grass. Why is that? Oh, because we need to... So we're only checking for sand in 1 unit. We need to actually check grass as well. So if it has sand or grass within a unit of 1, and so then we check for water. So if we're next to sand or grass, then we search for water, and if there is, then we turn to grass. This is confusing, but this should work. Hey, good morning, Story Game Artist. How are you doing today? So there's our soil, there's our water. We get that 1 line of sand, and then we get grass. So that's kind of nice, but then we don't see it here because it's underwater. If we go back to our terrain shader, we remove the smoothing. So let's just do, what was this before? So if we just do return particle.color. We're still not going to see it because it's under the water because of our height smoothing. So it might need to be a little bit thicker than 1 unit. So if we go back to the transform job, and we make this a radius of... you asked how to deal with beavers in Made. You do so using sheep, obviously. Oh, this is in... I didn't put the names together. So you made the game in Scratch, is that right? Okay, if we bring that smoothing back, first of all, why are we not culling their back faces? Let's fix that. What is this? Why is this two-sided? There we go. Okay, so we actually did have 2 sides to our terrain. Yeah, sheep brain. You can press H to bring up hints, A and D to flip between the 2 pages. Ah, I think so. I found H to bring up hints, but I did not find A and D to flip between pages. So there might have been more that I missed. I'll go back and check that out. Okay, so I'm not actually liking this whole sand thing because we're having to create such a thick sand border. Which I don't want. If we go back to this guy, the radius of 1, what does that look like? It's our hot pink soil, And add water. Yeah, we just can't see that tiny little sand patch. We can see it in the embroidery, but we can't see it in the actual simulation. I'll have to think about that a bit more. Let's fix up these colors though, so we're not using hot pink. So soil will be a richer brown. Sand will be a lighter brown. Now that I refresh myself with a bit of block-based coding, I actually understand a bit of what you're talking about with real code. Oh, cool. That's awesome. I'm always very happy to answer any questions too if you have them. But that's super cool. Yeah, so I like it here. I like having the sand buffer there, but we'll need to figure out how to make that more prevalent in the real world. It might actually be... enough to just reduce the... There we go. Don't need that water to be so deep. Okay, so that now we can actually see a little bit of the sand. That's kind of cool. Let's play with that a little bit more. Okay, so this kind of pixelation is kind of bugging me a bit. So I think what we'll do is try and fix that up. So my thinking is, to recap, for each pixel within the cell, we want to weight the blend towards the nearest neighbor. So if we're in the middle, it looks like it is now. If we're on the left side of the cell, we want to weight our color blending towards this side and vice versa on the other. So let's take a crack at that. Why are we auto scrolling? There we go. Okay. So get smoothed color. So we take our UV and we convert it to a grid position. Let's do, I think what we want to do is basically just keep the portion of the UV that's getting cut off when we cast it to a float. So let's make an overload for this. UV to grid pause. That also returns a remainder, something like that. And this will be float, float. Hello, Fern. How's it going? I'm late since I completely forgot about the stream and went to Little. I realized halfway through the shop that you were streaming, rushed rushed through the rest of the shopping. Oh, awesome. Appreciate that. Sorry to rush your grocery shop. Okay, so we don't want to do the floor here. That will, I mean, effectively get done here. But here what we want, so the remainder should just be this modulus 1, modulus 1. That should give us what's left over. So that will give us a kind of normalized coordinate within the particle that we're in. So let's grab that. What is it? Oh, that's fine. We'll do that here. Check pause, check pause. Oh shoot, we don't want that. Oh no, sorry, yeah, we do. Okay, so float 2, remainder. So, how do we actually want to weight this? What are you working on right now? So where we got to today is we've improved the terrain generation a lot. So we've smoothed out the kind of very harsh edges that we had before. We added some color blending, but the issue that we're having is that the color blending is very kind of pixelated. So we need to make them kind of transition a bit more smoothly within a given particle. Making pixels the right color when they're a certain distance from water. Yeah, that too. So we added a sand particle type. So there's always a sand buffer between water and grass. So you can see that there. So we add water, and if I put soil on top of it, it'll create a little sandbar between that and the grass. One thing we don't have though is if you add water on top of grass, it doesn't create sand. I don't know if we want that or not, but for now, anyways, we can create sand that way. Looking better than last time I looked anyway. Awesome. That's perfect. Okay, so we got to think through this a little bit. So let's bust out the handy old grid. So if we're drawing this pixel here, or this particle, and we're currently drawing this pixel, right? We want to take more influence from these colors than from these colors. So we can do that with a lerp, but the radius logic is kind of making that a bit more complicated. Because we want to take more from this side, I guess. Yeah, okay. So we want to take more from this side. I think we can normalize this. So if we're less than 0.5, we take more influence from this side. If we're greater than 0.5, we take more influence from that side. I'm just not sure how we want to deal with the radius. What if we do this? In the case of color, what if we get rid of the radius and we always just use 1? And then it's just a linear blend across that. So what we can do is we'll just kind of hard code top, bottom, left, and right. It's gonna be a little redundant, but just bear with me. So we'll do that. We'll clean this up in a minute. -1, -1, 0, and +1, 0. So this should be essentially equivalent to a 1 pixel check. And so we can get rid of this, get rid of that, get rid of that. Okay, and then we can apply our smoothing. So let's do this. So to normalized weight is our remainder. This will be remainder minus 0.5 over 0.5. And otherwise, it's just remainder over 0.5. So this will give us kind of like a normalized weight for each axis. This is so messy. The joys of doing this stuff on stream. What is the problem here? Expected 2, actual 4. What are you talking about? What? Oh, of course. Okay, I'm drastically overcomplicating this. Dot y. Oh, y. All right. Why is the 0.5 thing going? So here's my goal. Let's say we're inside of a cell, right? So inside of a cell, this would be 0, 0. This would be 1, 1, and then 0.5 is in the middle, right? Let me use a bigger cell here. So this is 0, 0. This is 1, 1. This is 0.5, 0.5. So we're inside of a single particle, and we want to know how far we are and which neighboring colors we should influence, or should influence us. So if we're less than 0.5, we want to take color from this side, right? We want to take the neighboring particle to the left. And if we're greater than 0.5, we want to take it from the right. This is basically going to give us the percentage that we want to take from that. So actually this should be 1 minus. 1 minus. So it's giving us the weight from the side. So Garud shade it. Garud shading. An estimate to the surface normal of each vertex in a polygonal 3D model is either specified for each vertex or found by averaging the surface normals of the polygons that meet each vertex. Using the estimates, lighting computations based on a reflection model are then performed to produce color intensities of the vertices. I'm not sure how this relates. Why even weigh the other cell into it? So we're trying to basically blend. So right now we have this very pixelated look, right? So if I actually completely do away with the blending, if I bring this back, so we're only taking the color from the current particle, right? We get these harsh edges. What I want to do is given an individual particle. So for example, this guy here is a particle, right? This guy here is a particle. And every pixel right now inside that particle is going to get the same color. What we want to do is that the pixels, so inside the particle, the pixel here is going to be a bit more green because it's going to get this neighboring particle color. The pixel here is going to be fully brown because its neighbor is also brown. And then we also have to do the same thing on the y-axis. But we're trying to basically get influence from our neighbor and then weigh that influence so we get a smooth gradient. It's like making a pizza one slice at a time. If that slice is next to pepperoni, then it has a few pepperoni. But if a slice on the opposite side is next to pineapple, then it's pineapple. Yeah, exactly. Yeah. So what this really should look like is a smooth gradient. Should look like is a smooth gradient that looks like so. So if I grab that, and I grab that, what we want here is a linear gradient like so. No, like that. And then obviously the same thing for the y-axis as well, right? So maybe be a bit more accurate to do it like this. Something like that. dx dy, exactly, except so dx dy works per pixel, we can't use that because we're working like per particle. But if we were working per pixel, then yeah, dx dy would be perfect. Hungry, shame there aren't cookies in the cupboard. You were just at the grocery store. Should have got some cookies. It'd be a diagonal shade. Yeah, exactly. So what we need to do, and I'm absolutely terrible about thinking about this stuff on stream because I cannot think when you guys are watching me, is yeah, we need to figure out that weighting. So here's my goal with this messy little bit here. Don't you have info on the shading? Depends what you mean. So ddx ddy won't work because ddx ddy works per particle, or sorry, per pixel. So that would only work on like the edge here, like right here it would work, but all the way over here it won't, because we're still like every pixel here by default is going to be in the same particle and they're going to get the same color. Not enough info past the shader. So the info that's passed to the shader is basically a grid of particles that looks exactly like this, right? So we have just an array of particles. Each one has a color, but the resolution of that's very low. We're passing like a 200 by 200 grid, and we have, you know, an infinitely large terrain that we're then applying to that too. So that's why we're getting this like really chunky pixelated look, because you know, the particle simulation is 200 by 200. So the smooth, like the simple blending that we could do, we were doing before, is just going to average out all the neighbors kind of evenly. Right? So it just averages them out. So here we can see, you know, inside this particle, it's averaging brown and green to get this kind of like semi-gradient. And what we could do, if we go way back, is we can pass like an arbitrary, I can't go back far enough. We can pass an arbitrary radius to blend further, but then we're just going to wash out all the color. So what we really want is exactly this, where inside of a particle, we create that gradient from the neighbors. And actually, maybe that's an easier way to think about it, is we're just creating a gradient from our neighbors. What if we did like a three-way lerp? HLSL three-way lerp from left neighbor to our color to right neighbor. Yeah, okay, actually, so this is essentially what we're on track to do. So let's get rid of this. Let's do this. So float 3, top color. Oh, sorry, float 4, top color. 0. We'll move this into a function in a minute, but top color equals, so we don't need the sum color anymore. We don't need the count. Get rid of those. Top color is particle.color. You need some info on neighbors. Yes, so I do have that. Yeah, I think this is going to work, guys. One sec. I'm famous last words, but I think this is going to work. So let's just check this real quick. So top color equals this dot get, this, not this. So get color, grid pause plus into 0, 1, yep. Let's be -1. And then we'll do left color, right color. So, okay, get rid of this guy. If our x position, remainder.x is greater than, sorry, if it's less than 0.5, we are going to lerp from left to this color. And that'll be remainder.x over 0.5. If it's greater than 0.5, we're going to lerp from this to right, remainder.x minus 0.5 over 0.5. Does that make sense? And then we do the same thing on the y-axis. Let's just try this on the x. I'm disturbed by the 0.5 thing all over the place. So the reason for the 0.5 thing is because we're normalizing the coordinate, right? So if the current pixel being shaded is, if the current pixel we're shading is this guy here, right? So he's right here. So this guy is at 0.5 inside that particle. If the current pixel being shaded is here, then he's at 0.5. Does that make sense? So we're just normalizing it. So we want to basically from here to here, just looking at the x-axis, we want to go from the left particle to this color. If we want to, if we're on this side, then we want to go from this particle to the right color. It's not normalizing, it's adjusting. It is normalizing, right? Because in this lerp, so if the current x is between 0 and 0.5, then the lerp is from left to this over 0.5. Does that make sense? Do it from the start and don't deal with it from there. I'm not sure what you mean by that. Do it from the start and don't deal with it from there. Sorry, I don't understand. So flip for this equals this, no. What is it? Get color. One sec, let me just do this on the x-axis and we'll see how wrong I am. Because you very well probably are right. So this is this color, right color, and forget about the y-axis for the moment. Yeah, sort of. So we are getting a gradient. We're getting a gradient, but why is this guy green? Fix up the 0.5 thing at the start of the shader instead of the endless 0.5s throughout the shader. You're subtracting it all over the place. I'm not subtracting it. I'm not subtracting it anywhere. All we're doing here is we're doing a three-way lerp from A to B to C, right? Using a single value that's from 0 to 1. So if the t value is less than 0.5, we're going to lerp from A to B. If the t value is greater than 0.5, we're going to lerp from B to C. Unless I'm completely misunderstanding what you're suggesting, Mr. Coder, we're not subtracting or modifying anything. We're just doing lerp A, B, lerp B, C. You can see minus 0.5. Minus 0.5. Oh, this bit. This is because, so on this side, this is the only bit we do have to normalize. You're right. We do have to normalize this because if this, so here remainder.x is somewhere between 0.5 and 1, right? So in this case, and only in this case, if you just do divided by 0.5 here, you're always going to get higher than 1. We need to go, so we're 0.5 to 1 here, and we need to convert that to 0 to 1. Right, so we're converting 0.5, we're converting a space of 0.5 to 1 to 0, 1. if you just did remainder.x divided by 0.5, it's always going to be greater than 1 here. If you just did remainder.x divided by 1, you're gonna your t value is going to go from 0.5 to 1. It's not going to go from 0 to 1 like we need. Sure, you're normalizing, but you shouldn't need to. You do. For a three-way lerp, you do. I don't know of a way to do this without that. Okay, so left to this, this to right. It's the whole something is wrong if you smell this code. I'm going to agree to disagree with you. I don't see what the issue is here. Other than like 0.5 as a constant is used, you could put that into a variable or define that or something like that. But for a three-way lerp, I don't see any other way to do this. Have there been any updates on what you have on itch since I last looked? No, there haven't been. So I think what we're going to try and do is update the itch page every week. So we're getting due for another update. But because we don't have any way to actually like, I can go into the scene view and I can look at the 3D world that we're creating. You would still only just see this. And not much has changed there. We did do some optimizations today, so it'd be nice to get that up and just see if it's running better on anyone's computer. But I think everyone had it running at 60 FPS anyways. So I don't think anyone would be able to tell what's changed. Once we can actually transition into walking around in this kind of version of the world, then I'll definitely get it updated. Okay, so we are getting a gradient that almost looks right, but we're kind of jumping ahead a little bit here, it looks like. X. So if I just want to actually debug this. Let's return remainder. And so we should see little gradients all over for each pixel. Remainder 0, 1. Yeah, so we're seeing these like little UVs, right? So that looks correct to me. Is it maybe the condition of remainder.x? Maybe. Maybe. So, okay, so for this particle here, right, so the boundary is here. I just want to save this for a second. And then if I switch this back to there, this guy is getting, so this guy must be sand. And this guy's grass. And so we're going from sand to grass twice. That's not going to work, obviously. I'm betting, so if I just output the color of this, I'm guessing this is part of, yeah, so that's sand, that's grass. So we should see, what should we see here? We should see this guy turning to sand on the left edge, and this guy, see, okay, so here's our issue. So this guy's turning to grass on his right edge, this guy's turning to sand on his left edge. That's how we're getting this double issue going on here. So this whole idea is flawed. I did a bit more on a search on app data still being nowhere. Unfortunately, no solutions. Just seems like it's going to have to put up with it. That's frustrating. The minus 0.5 times 2 thing, you want to fix that from the outer code if possible. Minus 0.5 times 2 thing. Where are you referring to, Mr. Coder? Less than equals instead of less than? That will, I mean, yeah, that'll modify like a tiny sliver here, but I don't think we'll be able to see the difference there. Yeah, blending on the X but not on the Y. Yeah, we're just trying to get the X going for now. But I think there's a flaw with our whole premise where this particle, let's go back to this. So this particle's sand. This particle's grass. The way we have it now, which I'm now realizing is wrong, is along the x-axis, this sand particle is transitioning to grass to match its neighbor. But then the grass is also transitioning to sand to match its neighbor. And that's how we're ending up with this kind of like double gradient. So is the solution to only blend in one direction? So only blend from like left to right? So this would go sand to grass, and this would just start as grass and transition to also grass. Let's do that real quick. So everything's going to kind of like lean to the right, essentially. Which isn't ideal. And it's still quite blocky, but let's add the... so we'll do left to right and bottom to top. So outcome equals... sorry, this is backwards. Sorry guys, I'm trying to think and also keep up to date on the chat. Finally just found a way to find the app data. Awesome, Fern, if you could send me that, that'd be great. Do you want me to send the embroidery folder? Yes, yeah, that'd be perfect. Where does remainder get updated? So remainder is inside this function. So it's assigned in the output. So it's basically, we convert our UV to a grid position. So that's like an integer grid position. And then we're keeping the what do you call it? The remainder, just using a modulus 1. So that's like what's left over inside that grid position. So at this point, we might have like grid position. So if this cell is 0, 0, this is 0, 1, this is 1, 0, and this is 1, 1. This is 1, 1. If we're at a particle that's like at this point, we might have like 1.4, 1.25 or whatever it is. So the remainder is 0.4 or 0.25. What's left over, how far into that particle we are. Just mix the colors at the edges. Yeah, we will. Right now we're just doing a linear blend, but we'll do like a smooth step or something like that, so it's a bit less ugly. Now you're talking Garoud shading. I'm gonna have to look up Garoud shading after. I'm not familiar with what that is, and from just a quick glance at the Wikipedia article, I didn't quite get the reference, but you're probably right, Mystic Coder. You're probably right. You can optimize that out into less instructions. Optimization we'll get to in a minute. I just want to get something working. So lerp from 0.5 to 1 and from 1 to 0.5 instead of 0 to 1 and 1 to 2. Optimize from Plucky, I think what you're referring to is what we were doing a second ago, but then we're kind of like we're doing like a double gradient. Let me just add in the top color and then we should see. So this should be this color, right color. So we're kind of always going from left to right. And then we're going to go from bottom to top. So this is outcome, top color, remainder.y. Okay, we're kind of getting something. Let's get rid of this water plane. Mystic, you're talking about this guy here. Cool. Okay, so let's debug a single particle here. Yeah, there's something weird going on. I think it's because we're doing this like double lerp thing. I think there's probably a better way to actually blend between the colors. But let's do, okay, so outcome starts as this color. Then we blend in the right. Then we blend in the top. There's probably a better way to do that. Don't need left anymore, don't need bottom. Actually, that's handy for debug. So if we just look at this particle, so we have grass here, sand here. So this guy is going from sand to grass, that's correct, but then this guy brings in sand for some reason. Why are we doing that? Oh, because he's got sand beside him. So on the x-axis, this guy's going from... Oh, this is all messy. This is so messy. Hmm. What do we want to happen? If I go back to this. Come on. There we go. So what should this actually look like? What we want is something that looks like this. A bit of a more of a gradient, but essentially something like that. So we're going up and kind of in. So it only fetches one cell to shade against neighbors. Currently, yeah. So we had it earlier. We were kind of doing just like a kind of general blur. But we still ended up with like these kind of like blocky segments. So I had this brilliant idea to go on a side tangent like this, but clearly it's not working. GIMP is so gimped, yeah, it is. So do you have all 9 cells available when shading? Yes, we have the entire simulation. We have 200 by 200 cells in an array. All right, I've sent out my gaming email to you. Thank you. I appreciate that. All the info, marching cubes. Marching cubes would be kind of a lot. But like generally, basically what we want is just a blur. I should have kept what we had before. Smooth color. So before we had something like we were taking this as input, but just to show. For int x equals minus radius, for int y equals greater than radius. Yep. And this was some color int count. What was this? Grid pause. Yep. And then this was particles. Grid pause to particle index. Dot color. And we had to check that this is actually valid. If not, it's something like that. So that does blur it. But because it's not weighting the blur in terms of proximity, right? Because we're projecting this like tiny 200 by 200 particle simulation onto a massive terrain. So if we just blur by sampling the neighboring particles and taking an average, it's not taking like the proximity into account. So like in this case, every pixel inside of here belongs to the same particle, and so they're all going to get the same result, right? So we still end up with a block where everything in that block gets the same result. What we needed to do is to weight that so that a particle here, or sorry, a pixel here, come on. Why am I drawing so... Oh. A pixel here, right? So if we're drawing this pixel, it needs to be taking more influence from here than from here, right? Or even from the center of its own frame. So that's what we're trying to do. It's kind of like a three-way blend. So that's uniform to the shader. Yes. Yeah. So every pixel has the same understanding of the particle structure. You need to blend all 4 vertices. Seems obvious. That's what we were trying to do with the three-way blend. That's exactly what we were doing. The problem with that we ran into was, if we go back, I need to start keeping versions of the code so I can actually show you, or I can quickly jump around. So we go back to, oh geez, I don't think my history is going to go back far enough. But that's exactly what we were doing with the three-way blend, was to account for every, I can't go back far enough, was to account for every direction, or blending on both axes. I think I can just explain what the problem was, though. The issue was, so if we do it like that, right? So inside this guy, so this pixel here, he wants to be sand, but he's going to start bringing in influence from grass. This guy wants to be grass. He's going to start bringing influence from sand. And we ended up with a kind of double gradient that looks something like this. Where this guy's kind of transitioning to grass, and then this guy is going the opposite way. And so we end up with like kind of like a double gradient. I just looked at the app data text file. It's a lot of scribbles to me. Hopefully I can interpret it. Surely the pixel shader lerps. What's the shading mode on the draw call? What do you mean by the shading mode? Is it flat? That's... I think you're thinking that this is like kind of like a... I don't know how to explain it. We're not relying on any kind of like built-in blending or shading model or anything like that. That's what we're doing. What if sand specifically doesn't blend, but things blend toward it? Would that solve? I mean, so then we would have the same issue though if we have like rock and grass or soil and grass. Like we'd have to define rules for like every combination. I don't think that's the way to go. I think we can do something a little bit more generic. Use this, but instead of using the color from the neighboring particle, mix them beforehand, then the color approaches each other. Use this, but instead of the color from the neighboring particle, mix them beforehand, then the colors approach each other. I'm not sure I understand, Pucky Silver. Right, so you blend all 4 corners. The 0.5 thing troubles me. I know you're worked up about the 0.5 thing. We're not using that anymore. That's gone. But I think actually that we need to go back to that. So I want to get back to the kind of 4-way blend. So that was if... Just bear with me. Don't get angry about the 0.5 thing. So if we do this, right color and left color. So this was... So for lesson 0.5, we're going from the left to the right. Oop. This is left. Bear with me, guys. Left to this color, or outcome. And this is remainder.x over 0.5. Okay, so this is going to just blend on the x-axis. Nope. So here's where we got into trouble with that. Where for a given particle, we're kind of ending up with a double blend. So if we just output the current color, so this is just outputting the particle simulation. So we have a sand particle here, and we have a water particle here. If we blend them, we end up with a double, because we're going from sand to water, and then sand to water again. Yo, Simtem, how's it going? You have red-blue, instead of blending from question to red to blue and red to blue to question, you blend from... Sorry, Pucky, I need to read that again. Instead of blending from question... What is question? Instead of blending from question to red to blue and red to blue to question, you blend from question to red to purple. Oh! I think I know what you're saying. So you're saying if we mix the colors first and then lerp to the mixed color. Let's try that. So we can do just a simple kind of average of the two colors. So left color plus this color. And then we work from the blend. Do the same thing here. Aha. Pucky, if this works on both axes, you get a medal. I don't know what that medal looks like, but you get a medal. Okay, let's quickly clean this up. Okay, so we don't need all this. So float T and float for blend. So blended equals this. T equals... no, hang on. Before we start cleaning things up, let's just get this working. Okay, so now we need to do the vertical axis. So Y. This is bottom color. And that's Y. And give me 1 second, guys. I gotta let my dog out, just crying at the door. I will be right back. But Pucky, thank you. I think you've solved our problem. All right, sorry about that. We are back. Simtem, I only caught a bit of the first stream. How long till this game jam ends? It ends August 31st. But I'm only working on this game on stream. I did one little experiment off stream earlier today, but aside from that, I'm only doing this on stream. So yeah, I think in terms of like hours, we have maybe like 20, 30. I'm not sure. But Pucky, I think you've solved our issue, which is great. Yay, your lovely dog. Hello, Chesley. Her name's Beans, not Chesley, but oh, Chesley, of course, Chesley on the BRB screen. Do you think I should use Unreal or Unity to make horror games? I want to add narrative to the games. You know, what's your take? I know you started with Unity, but stuff has changed since. What would you do? I would just what would I do? I would basically do some tutorials and see what feels more comfortable for you. I think Unreal does have some great strengths for like narrative driven horror games specifically because more realistic or immersive graphics tend to lend themselves better to horror. It's easier to be scared in something that feels real than it is for something that feels like stylized. So Unreal does have a lot of benefits there, but I honestly don't think you can go wrong in either engine. I think you're kind of fine in both. So I would do some tutorials in both, get a sense of what feels more comfortable for you, and just go with that. Hey everyone watching the stream, care to expose yourself in your background in programming? Fern, here's my background in programming, none. Okay, so we're bringing in the y-axis here, and we're getting a little bit... I think we need to be a bit smarter about the blend. So right now we're doing linear in both axes. I think we can potentially ease that a little bit. So let's see. We can do... What can we do? So we look at just the x-axis again. We want... The particle above is water. So we shouldn't really be using the x-axis as any kind of influence at this point. So we want more of a... we want more of a kind of circular shape here. So what if we did... what if we did... Is it easings.net? Yeah, here. What if we did like a in-out... Something like this. Okay, easing.hsl. Just doing a little bit of cleanup here, one sec. Sorry, not left and right. Let's do A, B. And so A is outcome, B is blended, T is this guy. So this should look the same, more or less, just with the easing. And then if we do the same thing on the y-axis, And this is the bottom color. Smooth step. Yeah, I think that's probably in our future. Maybe you need to take the diagonal particles into account. Actually, we can do the smooth step instead of the easing. Good shout. Do that here as well. Nope. What am I missing here? Why am I getting wild results when I switch to smooth step? Maybe you take the diagonal particles into account. Yeah, I think that's kind of what we're trying to do. Mystic Coder, I would love to hear the solution for that. I think I am very, very confident it has to be this way. Okay, let's blend in the vertical. Normalize outside the shader. We're not, this isn't a value that's, the remainder thing is not a uniform. It's not something that's being passed in. Thank you. Thank you. Thank you, Pucky. Yeah, there we go. Cool, cool. Right. This is top color. We'll clean this all up in a minute because there's a lot of redundant stuff in here. The three-way lerp is not, in my opinion, one of those things, though. Let's visualize this without the smoothing. So we are getting, what are we getting here? Okay, so here's our grid. We have a particle starting right here. And halfway through, it's kind of jumping colors. So we're good on the x-axis there. On the y-axis, we're missing something. Y. That's why. Okay, we're kind of getting something. Swing back the smoothing. We're still getting a harsh edge. I think this is the end of a particle. Let's see though. Yeah, that's the end of a particle. Mystic, I honestly do not see what the solution is for that. If you have a solution, I would love to hear it, but I don't think we're talking about the same thing. You can have a single lerp by lerping from the blended color of either side to the other. Let's give that a shot. Blended of either side. Yeah, I'm not sure about that, Pucky. What genre is your new commercial game going to be? I haven't shared anything about it. I'm probably not going to share anything until next year, unfortunately. I've been talking to a PR firm about kind of like the strategy for announcing and stuff like that, and yeah, it's kind of unfortunate because I was so used to working in the open for Farewell North, but for this one, probably not going to announce it until like a few months out. Only thing I can really say is it's very, very different. When I learned shaded-coded back in the 90s, don't perform operations that need performing. I mean, that's just a good general practice, absolutely. Where we differ, Mystic, is in our interpretation of what needs to be done. I don't see how you get away without the minus 0.5. I know you're going to keep harping on this. I'm leaving it. I don't see what the solution is. Again, I'm just going to explain this one more time. We need to lerp from A to B, to B, come on, to C, right? We have one t value that goes from 0 to 1. So if t is 0, we want A. I don't know what this notation is. If t is 0, return A. If t is 1, return C. And if t is 0.5, return B, right? So we're doing a three-way lerp here. I don't see how you do a three-way lerp without the 0.5s. Don't pass in anything that requires 0.5 adjustments. Nothing's being passed in. The value of t is a calculated value. .5 is never being passed in anywhere. If you have a concrete suggestion for how to solve this, I'm absolutely open to implementing it, but I don't see it. IMO, finding a way that works is priority number 1. Yeah, agreed. Maybe 0.5 won't even be in the final solution. Mystic, I'm just going to ignore these comments because it's not helpful. If you have a concrete solution, I would love to hear it. To me, like the fact that we're doing all this logic twice is the more redundant part, and I'd love to get that down to a single thing, like once for the vertical, once for the horizontal. I'd love to get that merged down, but honestly, the bigger bottleneck for now is falling sand simulation on CPU or landscape generation. Yeah, agreed. The CPU is absolutely the bottleneck. The GPU is hardly doing anything. I appreciate that you're trying to be helpful. I really appreciate it, and I'm not trying to get frustrated with you. So don't take it personally, but when you have 40 people looking over your shoulder and one person just kind of keeps harping on this thing and we don't agree on it, it gets to be a bit. So I'm sorry if I'm getting frustrated. Okay, so we still have a hard edge on this side, on the x-axis. I think, are we okay on the y-axis though? If I take out the x-axis, what does the y-axis look like? Y-axis looks good. We are still kind of getting something on the x though. Is something here using the x-axis? Remainder.y, remainder.y, y. No. Why do we... Am I crazy or do we have a gradient there? Yeah, we absolutely have a gradient there. Why do we have a gradient on the x-axis? Out of curiosity, why did you pick Chesley to be a border collie? Is that my favorite dog breed? I do love border collies. They're amazing, and I was actually babysitting a border collie last week, and it was the most fun. The reason that we chose a border collie for it was just because They come from the border region of Scotland. They're like very endemic to Scotland. We see them everywhere here. And I wanted a dog that's like, you know, very intelligent, very athletic, very emotive, empathic, like all those kind of attributes. And I think border collies kind of like embody all of that. Plus I wanted like the sheep herding mechanic and all that kind of stuff. So there's a whole lot of reasons why a border collie, and I think they were kind of like the perfect fit. But yeah, that's why. It was kind of inspired by my dog, but I figured if you played as a Chihuahua, it would, I don't know, maybe feel a little bit different, a little bit off. Um, if I get rid of that, why am I getting gradient there? I don't understand where that gradient is coming from. Chihuahua would certainly not do sheep herding. Yeah, no, they would just bark at the sheep. It would be a very different game, just running around barking at animals. I wish there was a way. Hang on. Let's look at the remainder again. Flip for. Actually, remainder is not a useful term. Let's call it particle UV. So the particle UV goes from 0, 0 to 1, 1. That's correct. That's what we'd expect. Yeah, cool. And then if I just return the Y blending, why is there a gradient on the x-axis? Anyone have any ideas for that? Bottom, top, bottom, top. No. It feels to me like this gradient is kind of lopsided, where it's going like up and to the left. It's like on a diagonal, which doesn't really make a whole lot of sense. Does your dog play Feral North? I mean, sleeps on the keyboard often enough. Probably secretly plays Feral North. Yeah, yeah. She pretty much slept on my keyboard the entire time I was working on Feral North, so there's a lot of her in it. I don't see what could possibly be causing that. Like, it feels like this gradient goes like along this axis. Not quite that extreme, like that. I don't understand that. Maybe try hard coding top and bottom color to see if it remains. Let's try. So if we did bottom color is, let's say, red. 0, 0. And the top color is green. Let's do away with that for a moment. So it actually seems like it's not there anymore. I'm not seeing that kind of slant. Oh, no, I'm not seeing it there either. Did we change something else? Oh, you know what it might be, actually? It might be the post-processing. Let's do this. Camera. No, maybe not. Now I can't tell. I can't tell if I'm just seeing things anymore. I might just be seeing things now. Did you need to create the world on Feral North like this? No, the world in Feral North is a lot easier to create in the sense that like you can just use like normal terrain tools and all that. Like we're doing something very, very weird here. This is not a normal, definitely not a normal way to like create a 3D world. I see it too, maybe optical illusion. Maybe, hopefully, I think we're just gonna write it off as an optical illusion because I like mathematically do not see how that's possible. There's absolutely no influence from the x-axis here. So yeah, I mean, we're going to pretend that it's an optical illusion. And then on the x-axis, yeah, we're getting the right thing again. Getting a nice gradient. But we still have that issue where we're kind of getting a double gradient. So if we just do the right and vertical, so the kind of hard code the right and left to right and bottom to top blend, we're back at this. Let's see. So we get the X, get the Y. And I think maybe what we need to do is do this. For blend equals guess who's back? Hey Alex, welcome back. What did I miss? How's it going? Oh, you missed a lot. We're trying to basically create a gradient between pixels. So we've got a few versions of this. I think what we did at the beginning, and you probably saw, was a simple blur where we take all the neighboring particles and kind of blur them together. The problem is, because we're taking a small particle simulation that's like 200 by 200, and we're projecting it onto a much larger terrain, a whole bunch of pixels land within the same cell of that simulation. And so when we just do a simple blur, all the cells, all the pixels in that cell will get the same color, and we still get this kind of blocky look, right? Because they're all every pixel inside, for example, this cell here is going to equally, so if we're this cell here, it's going to take the color of this one, this one, this one, this one, right? All of the neighboring and itself, and it's going to average them out. And so in the end, every pixel inside this cell is going to get the same color, and that's why we get this kind of blocky look. So now what we're trying to do is we're trying to weight it so that a pixel here takes more influence from these neighbors than from these neighbors, if that makes sense. Well, idea, but offsetting UVs by half a point in X and Y directions. Offsetting UVs in X and Y half a point. If we did that, what would we get? Would we not just be shifting the whole issue up half? Does upscaling and downscaling produce the same effect as blur? Very similar. Yeah. It does a blur essentially. Use a matrix? In what sense? What about giving each corner a mixture of the surrounding colors and blending from there? Then the tiling should work perfectly. What about giving each corner a mixture of the surrounding colors? So the issue is, I think that's kind of essentially what we're doing here. So if we just look at this, the blend on the x-axis, like so. Oh. If we just look at the blend on the x-axis, the problem is we end up with like a double gradient. So if we focus on this guy here, if I just look at what the actual color is, so we have water and then sand. And what's happening is, so the line is here. So water blends to sand and sand blends, oh no, hang on, sorry, this is a different one. Sorry, we've gone through a bunch of different versions of this. So we just look at this one, okay. So we end up with, actually, hang on, is this one right? I don't even remember now. Okay, so we should see like the sand kind of bleed into this and there. So yeah, we kind of do. What's the issue with this one again? Is it just when we introduce the vertical as well? Yeah, we're getting these kind of like harsh borders. So like here kind of looks good, but then for some reason we get like a harsh border up there. Matrix multiply the 9 cells, don't overthink it. Matrices are not my strong suit. I mean, we've seen I don't have a lot of strong suits, but matrix multiplication is definitely not one of them, so I'm not even sure what that would do. Right now you're not taking the diagonal cells into account. True. Ah, that's true. Yeah. You get borders if you don't check in a circle. Yeah, so it's the diagonal that we're not considering. Fair point. Yeah. So Pucky and Lux, you guys are on the same page there. Yeah, so because we're not taking the diagonal into account, we're always going to get the harsh border. Yeah. I'm losing steam here a bit, guys, if I'm honest. My brain is about fried, but let's see if we can introduce that. So how do we go about that? So right now, if we're focused on this cell, we're blending from this one to this one, and we're blending from this one to this one. Giving each corner a vertex, giving each corner slash vertex a color would mean no harsh borders. We don't have, so that's one thing we could do. We don't currently have actually a vertex per particle. We're kind of projecting an arbitrarily sized simulation onto an arbitrarily subdivided, what do you call it? Grid, plane. So you have a right matrix, right, cross multiply, matrix multiply, 3 by 3 in out to a factor. I understand what most of those words mean in isolation, but I don't. Matrix, man, I don't want to do a matrix multiplication tutorial on stream. I don't understand matrices whatsoever. I'll be completely honest with you. Like, I understand the concept of a matrix, but like, I don't understand what multiplying is going to actually do. So I would literally just be shooting in the dark. So I'm not saying that that wouldn't work. Probably would. I don't know how to do it. I remember working with this with SDF functions. So SDFs, if we represent this as a square and we get the sign distance, that would tell us how far into the square. So we kind of basically actually already have that because we do have the UV coordinate inside the square. So if we represent that, if we render that, sorry. So we can see each square here. So that's 0, 0, which is black. And then as X increases in the R channel, we can see we're going up to 1 and then 1, 1 when we bring in the green on the Y. So 0, 0, 1, 1, 0.5, 0.5. Yeah. Kind of fun to use. SDFs are fun to use. You need to understand matrix multiply. I wish I did, but I don't, and I'm not going to figure that out on the stream. You don't have to overthink it. If you want to tell me the code to write, I will try it, and then I'll try to understand it. But I'm not gonna. I would literally just be guessing. If we went down a route of trying to do this with matrices, because I just don't understand them. I'm just gonna do this for the fun of it. This is a terrible, terrible, terrible idea. But what if we did this? The least optimized thing ever. Outcome plus get blurred, UV. No, that doesn't work. Yeah, I mean, I obviously I understand the concept that you can multiply two matrices together, but I'm not sure what matrix you're talking about. Like you can take the 9, the current cell and its 8 neighbors, so you get a 9, a 3 by 3 matrix, and then multiply that by what? All right, guys, I think I'm gonna call it there because my brain is completely dosed. But yeah, thanks for hanging out, watching me struggle with this, and I'll go do some thinking, some research tonight, and see if I can come up with a strategy. But yeah, thanks for hanging out.